this video, we're talking about simplifying decimal equations, and I've got a couple examples here of equations where we have decimals. So in this first one, we have 0.2x plus 0.5 is equal to 0.1. So we have three decimals, and sometimes you'll have a mix of whole numbers and decimals. Sometimes all of your values here will be decimals. It doesn't matter. The process for simplifying these types of equations is always going to be the same. We're going to look for the smallest decimal and then multiply by whatever power of 10 we need to make that decimal a whole number. So for example, I have 0.2, 0.5, and 0.1. All of these end in the tens place, which means I need to multiply this entire equation by 10 in order to make all of these decimals whole numbers. So what I can do here is put parentheses around my equation and put a 10 out in front. And now this is the distributive property where we distribute the 10 across each of our terms. So we're going to say 10 times 0.2, 10 times 0.5, and 10 times 0.1. And when we do, we should get whole numbers. So 10 times 0.2 is going to be 2. Remember, when we multiply by 10, we move the decimal place 1 to the right, so we get 2.0, or just 2. Here we move the decimal place 1 to the right, and we get 5, so 2x plus 5. And we move the decimal place 1 unit to the right, so we're going to get 1. And now this is just your equation solving. We want to solve for x, so we'll go ahead and subtract 5 from both sides of our equation. We'll get a positive and a negative 5 to cancel, and we'll be left with 2x is equal to 1 minus 5 is negative 4. Dividing both sides by 2, we get x is equal to negative 2. Now here's the same problem. I just have smaller decimals than I did in the first problem. Instead of 0.2, I have 0.02. Instead of 0.5, I have 0.05. And instead of 0.1, I have 0.01. All of these decimals end in the hundredths place, which means we're going to have to multiply this equation by 100 in order to turn all of the decimals into whole numbers. So 100 times 0.02, remember when we multiply by 100, we move the decimal point over 2 places, and so we're going to end up with 2. So we'll have 2x plus 100 times 0.05 moves the decimal over 2 places, so I'll get plus 5. And then 100 times 0.01 moves the decimal over 2 places, so I get 1. And again, I have the same thing here, so I already know that x is going to be equal to negative 2. Now what happens if I have decimals that end at different decimal places? 0.1 ends in the tenths place, 0.02 ends in the hundredths place, and 0.004 ends in the thousandths place. Well, remember, we always want to take the smallest decimal and multiply by whatever value is going to make that decimal a whole number. Well, the smallest decimal is this 0.004. This one ends in the thousandths place versus this in the hundredths and this in the tenths place. So in order to make this 0.004 a whole number, we need to multiply this whole equation by 1,000. So 1,000. When we multiply 1,000 by 0.1, let's get more room up here. We have 1. We're going to move the decimal over 3 places. So 1, 2, 3. We fill in with zeros here, and we get 100. So this is going to give us 100x. When we have 0.02, and we multiply by 1,000, we're again going to move the decimal 3 places. So 1, 2, 3, fill in with zeros, and we have 20. So we'll get plus 20 is equal to 0.004. We move the decimal over 3 places when we multiply by 1,000. So we get 1, 2, 3, and we just get 4. So 1,000 was what we had to multiply by in order to make this 0.004 a whole number. Now we can just go ahead and solve for x. We'll subtract 20 from both sides, and we'll get 100x. Positive 20 and negative 20 will cancel. 4 minus 20 is a negative 16, so negative 16. Dividing both sides by 100, we get x is equal to, because these 100s cancel, negative 16 over 100, which just becomes negative 0.16, because remember, this is the tens place, this is the hundreds place, so 16 over 100 becomes 0.16. And of course, we have our negative sign, so x is negative 0.16. And you might be tempted to leave this as negative 4 over 25 and just reduce the fraction, but because our original problem was given to us in decimal form, we want to make sure that our final answer is also in decimal form. If the original problem is given in fractions, you want to leave your final answer in fractions, but because it's given in decimals, you want to leave the final answer in decimals.